Okay, today is 19.1 day 2. This is the second day of vectors. So just a quick review of what we did yesterday first, and then basically we're going to be talking more about subtraction. We kind of hinted at it yesterday. We're going to talk a lot more about subtracting vectors and also trying to show you how vectors can be used in the real world. And I got a pretty cool example of that for today. All right, so just a reminder about yesterday. If this is a vector with an A on this end and a B on that end, is AB the same as BA? No, because the direction matters on these things. In fact, there's two big things about a vector. It's got this and this. Direction and magnitude. Okay, good. So the magnitude's kind of a weird one because it can be lots of things. It could be the weight of something. It could be how much force you're applying. It could be the speed of something. But direction is pretty simple. Except that we haven't yet told you how to describe like that direction. Would you agree that that's generally heading north and east? And so you could probably say it's sort of northeast. But that's not very mathematical, right? Now, could we do this with compass rose and say, okay, that's exactly 78 degrees? Yeah, that'd be a good way to do it. That's an option. Another way to do it would be to say, how far over does it go and how far up does it go? And that's the way we are going to be doing them a lot, where we'll say, okay, instead of saying that this generally is heading northeast, we can say it heads 8 units to the right for every 3 units it goes up, and therefore I could say it's an 8-3 vector. It's kind of saying it heads 8 this way and 3 that way. Kind of like tells you directions on how to get here. Over 8, then up 3. All right, so you write that like this. But we'll talk more about that actually tomorrow. Today is more about if I have AB and I have from B to C is this way, what would AB minus BC look like? Would you please sketch my AB and C and then tell me what you think AB minus BC would look like? I'm going to pause for just a second. Okay, I hope this wasn't super tough. BC normally goes that way, so what do you think minus BC would do? Goes the opposite way. Goes this way. That same length, magnitude, except in a different direction. Okay, so when I say minus something, does it change its magnitude? Nope. Changes its direction. Goes going the opposite direction. All right, so you should have said that that's kind of like the picture of it, but what's the resultant? Well, now this is going to be our C, and it's going to be that way. If I had just stuck with the original and said AB plus BC, the resultant would have been AC, like that. And this other resultant is totally different. It's up there. It's different length, all kinds of stuff. It goes a different direction. So the two resultants are quite different when you're adding versus subtracting. All right. A, B, C, and D. All right. Would you please sketch that and then tell me what would BA minus AD look like? BA minus AD. Okay, hopefully BA hasn't changed, right? And then AD, if I had added AD, I would have gone to there, and my resultant would have been this guy, but I'm not doing that. I'm subtracting. So hopefully you went that way, and your resultant should be that like that dotted line. Raise your hand if you did that right. Okay, good. Then it's not too much of a stretch then to start doing it this way and say, what's 2BA minus AD? I haven't showed you how to do this, but I bet you can figure it out. Remember, the resultant's what it's all about. You can draw the path. That's a great start, but you've got to actually say, okay, so then the shortcut would be this. Got to make that resultant at the end. All right, now I need you to work with somebody because there's a tough problem coming up here, and this will also give you a chance to compare on these answers. I'm going to pause for a second while I group you. Okay, I'm hoping this one wasn't too tough. That's BA, and then I'm going to do another identical one. I'm even going to use my smartboard's capabilities to make this identical. I'm going to clone it. There. That's 2 BAs. Get what I'm saying? 2 of the exact same thing. You just put them like head to tail. And then I got to still have this guy, but it's again going in the opposite direction. So, whoa, hold on. Let's grab the blue one there. Oh, come on. That one. There we go. Be good. Nope, not going to be good. Okay. I better move this out of the way so I can grab it easier. And then it goes that way. Okay. So, I can slide this back up. Final answer. Is that right? Kind of. That's the picture, but what do I need? The resultant. The resultant is then like that. Notice the direction is different. What is what? Did you draw the resultant kind of like that? Okay, good. Then you're good. Good question. Now, we can't call that D because D is over here. Okay, so I was asked, what do we do if we don't want to use D again and act like D is all of a sudden over here because it's not over there. I'm going to just say that we're going to say it's like D, but different, and so we're going to call it D with a little dash, which means it's called D prime. Say, our final answer is this arrow right here, and what's really important about it is its direction and its length, not so much exactly what you call it. Here's why I don't really need to run into that too often, because usually what we're going to have is labels like this, little a and little b, okay? And then I don't need the endpoints to be named. I just call them like little a and little b. So let's do one like that. Let's say this is little a. Let's say that is little b. Would you please figure out for me what negative a minus b would look like? Negative a minus b. Draw a picture what you think that would look like. Oh, by the way, when I said minus b, you could think of that as plus negative b, because minus b and plus minus b actually comes out the same. It's like this. 7 minus 3, or 7 plus a negative 3 comes out the same, doesn't it? So if you want to think of it as adding a negative, that'd be fine. Okay. Well, negative a means a, but in the opposite what? Direction. Okay, so that's like that. And then minus b, I could think of it as plus a b that's going in the opposite direction, right? So here's normal b, but b going in the opposite direction would be like that. And you remember you always add them head to tail, so there we go. Went off my screen a little bit, but I think you get the idea. And then your resultant would be heading in that direction, which I sort of call southwest. Raise your hand if you had that one right. Okay, good. Now, do you get if I wanted to make this 2A, that I'd have to double this part, and then I'd have 2 of them, so I'd have like 1 here and 1 there. And would that change the direction? Definitely it would. Let me show you. I take this and I clone it, so now I got 2 of them, and I put them back to back. Now my dotted line ray at the end goes from here down to there. Do you get that that's a slightly different direction? A little bit different angle. Yes? On the top of A. Okay, but the reason I had to go down there is because the tip of this has to touch the tail of this. Try to keep that rule straight that you can never have like the tails touching. That doesn't make any sense. It's got to be head to tail. Yes?
Yeah, but can we have the head touching the A's tail?
B's head, which is like, if we go like that. No. Yes. Oh, you can. Absolutely, you can. But if I go below it with this, and then I put this down here, it's going to end up with the same angle. Going from here to, I can't even see it, it's off my screen, but it would end up being the exact same direction and the same magnitude, so it'd be fine. Okay, so that's the first thing, is just like 2 of something. Well, of course, that leads to half of something. So let's say I have a new picture, K, Q, R, and what do you think I'm going to put? S. Yes, if you listen to radio around here, you'd probably know why. Then do you get KS would be the resultant of KQ plus QR plus RS? All right. So what, though, if I did 1/2 KQ minus 2 RS's? All right, so first of all, draw K, Q, R, and S on your thing, and exactly what angles, just get close. Yes, sir. Why does it have 2 directions? Oh, I shouldn't have a pointy arrow if that's what you mean. Oh, okay. All right, that should be a dot at the beginning. Good point. All right, and then I need a little thingy like that too. Draw what you think 1/2 KQ minus 2 RS would be. All right. Here's what 1/2 KQ should look like this green arrow. It's only halfway, okay? And that half doesn't change its angle. It changes its what? Magnitude. Doesn't change its direction, it changes its magnitude. All right, so there we go. There's my 1/2 KQ. And then minus 2 RS's. All right, so here's RS. I'll do it in blue. And if I just wanted to do plus an RS, I'd go like that. But since I'm doing minus an RS, I got to go the other way. So I'm going to go like this, but then change the head to be on the other end. Okay, what I'm saying? Now that would be 1/2 KQ minus just 1 RS. Now I need another one of those. Now I'm going to have to drag my whole drawing down a little bit to make this fit. So bear with me for a second there. That gives me enough room to work. And now I can make another one of those. I'll just use my cloning feature. And you can do that too on your iPad. You can do the copy feature. There. And I'm going to go off the screen, but I think you get the idea. There is 1/2 KQ minus 2 RS's. And then again, I need the final resultant. And I can't see it. It's up there, but that's the direction anyway. Yes? Yeah, I didn't need it. Not for this problem. All right. Next kind is where I'm going to give you the letters, but not a picture. And you got to figure out what happens. Now, I know that's like, wait a minute, that I don't even know what direction they go. You're right. But I think you'll figure out where I'm going with this when you see After you draw a picture out, and hopefully you'll realize, oh, it's got to be this. All right. I'll give you a simple one first. AB minus an AB. So if you think of that as going from A to B, right? And then what does minus AB mean? It's kind of like adding the opposite of that, right? And so then I am adding one that goes this way, and I'm right back where I started from, and the answer is the zero vector. And you can either write out the word zero, you can put a zero with a vector symbol over it. That's my favorite way to do it. This one, I would like zero vector as a great way to see. If you write out the word zero, I'd accept that too. Just a zero without the vector implies your answer isn't a vector, and it actually is a vector. It's the zero vector, which remember has how much magnitude? Zero. And what direction is it really? All directions. Okay. All right. Now, what if I did AB minus 2AB? I don't even know what the A and B look like. Again, you could be drawing them in a lot of different ways, but the answer would be something you could define. You wouldn't have to have a picture to do this. So if I decide AB this time is going to go like this, and you could have picked anything for this, then minus 2AB means I'm going to go back here and then go back the opposite direction, and so my final answer is that it's now going the opposite direction as it was in the first place, right? So how did you guys write that? I'm curious. Negative AB. I like it. Notice it's not negative 2AB. It's negative AB. It's the opposite of whatever direction you drew it in the first place. Yes? Is that a hand? Okay. All right. So now, this one's a little weirder. Bear with me. AB plus BC plus CM plus MA. Try to figure out where you are. I'll pause for a second while you do. All right, so now if I'm pushing down, and this is my down vector of 10 pounds of pressure, and I make this a 150-degree angle right there, all the way open. It's like a 180, except not quite. You know, it's a 150-degree angle there. This triangle will give you 10 this way. I don't know this. I'm going to call this F for my force. I know this is a 90-degree angle, and you can figure out this one and this one, and you'll have all the angles in one of the sides, and you can figure out F. Give that a try. All right, so here's our setup for this. This had to be 75 because it was half of the 150, and that's 15. So it's F over sine 90 equals, we might as well do one of the other sides that we know, so that's 10 over sine 15. Okay. Now, that shows you that a 10-pound force just got turned into a 37-pound force. You get that's a multiplier of about 4 times your normal strength. That's pretty cool. But how does 10 times your normal strength sound? Strength of 10 men. Okay, well, that'd be even better, right? That's at 150 degrees. What if this had been 170 degrees? As in, you haven't pushed it down as far. Get what I'm saying? It starts out at 180, and then when you start pushing it down, you start creating an angle. Now, let's say it was at 170. If it's at 170, then this isn't 75 anymore. It's what? It's 85. And if that's 85, how much is this now? 0.5, 5 degrees. And so everything stays the same except we change this to sine of 5 degrees. Would you please try that and tell me F is now 10 over sine of 5? Try it. Use a calculator. Yes, you may. All right. Did you come up with 100 and something? What was it? 100 and what? 114? Your 10 pounds of force has turned into 114 pounds of force. That's 11 times your normal strength. And that's when it's down at 170. Do you get that it'll get even magnified more if we move it to only 175 degrees? As in, at the very beginning, when you push at the very beginning, you get a lot of force. And then as you push it further down, you're getting less and less and less of the multiplier effect the further you push down. I know you're thinking, when you push down, you're pushing down harder. If you keep the same force at the very beginning, you have the most impact, the most multiplier at the very beginning. Okay, so that's just a good example of, I have two forces that are working together, this force and that force, which create that force, and that force can be figured out, and it will be a big multiplier. Again, as evidence, I would love to be able to do that example for you of moving a car in the parking lots. But you can move really heavy stuff with this method. Yes? An example of what?
An example.
Oh, that's a good question. I haven't tried, so I'm not going to be able to search for that right now, given how much time we have left in class. But, all right. So your homework for tonight, let me show you where it is. Everybody find day 2. Okay, here's the homework for day 2. All right. This one is kind of challenging. But don't say, oh, crap, I'm not doing that one. I want to see who's smart enough to figure that one out. You can. It's doable. But A and B are easy. I'd like you to put the little vector thingies over them just to make sure you get what's asking. They're asking for AC. But they say OA is A. That means this to this is little a. OB is little b. There we go. And OC is little c. It says that all in the directions right up in here. Okay. So now we've got A, little b, and little c. What is AC? Well, I'm going to draw it in green. Here's AC. It doesn't even exist, but we can make it. And it's kind of like saying, here's the answer. The answer is AC. What was the question that would have built AC? Would you agree that I could go basically like this and then like this to get there? So what's that called? When I was going this way, do you get I was going the opposite direction as A? So that'd be negative A. And then I got to go the same direction as C, so that's plus C. There it is. Negative A plus C. All right, and again, this is a challenge. A few smart kids are going to figure that one out. But if you can't, don't obsess all night over it. All right, next, if you're going to draw A minus B, we did practice these. Here's A, this would be A plus B. How do I do A minus B? It just goes that way. And then the resultant is that. Okay? So you're just going to draw me pictures like we did practiced earlier in the hour. And I got to tell you, you are not skipping anything until the very last problem. These are that kind where they don't have drawings. I did some of those with you. And remember, you can rearrange them. It helps a lot to rearrange them. And then this one is sit still. Thank you. You won't be able to hear anything on the video with your chairs sliding all over the place. That one is the skip. Now, everybody may skip the last one. It's number 15. Okay. That's all I got for you for today.